because it is Monday. It is 7 p.m. We are at the Milwaukee Makerspace, so we are going to model stuff in Fusion 360. Today, by request, we have a CNC project. We're going to make spoons, wooden spoons. I used to work at a shop that was on. Do you remember Felicia? Pardon? Felicia? Do you remember Felicia? Not really, no. No? All right, maybe it was long ago. But I worked for Felicia for a while. I worked for her business, making spoons, and I will show you exactly how we made them. I don't feel bad because the business doesn't operate anymore, so I'm not giving away her trade secrets because she has moved on to bigger and better things, and is making bicycles now. So anyway, spoons. We used to do them just like this. We would start the process on a CNC machine and basically make the shape that you see before you here. And then we would use hand tools to shape the handle and the back of the bowl, basically sanders. And you could do all this in the wood shop, just with belt sanders and disc sanders. So, but we're going to be making ourselves a nice little spoon shape. Hopefully this will go fairly quickly-ish so we can get into the tool path creation. Because that is what the request is today. Make some tool paths that we can take to a CNC machine. So I am going to start a new document here. Now that we're on the same page and we know what we're going to be making, I am going to create a sketch in my new document. And basically what I'm going to do to begin with is define the length of the spoon that I want to make. So I guess you can have a lot of creative freedom in this class. If you want to make a really big spoon, a really big wooden spoon, I support your choices. But know that this measurement right here, this line that we are going to make, so we'll click on create and then line. This line will set the dimension or the length of our spoon here. So as a general rule, I like to have some part of my sketch connected to my origin. Just helps me to keep things fully constrained, which will be kind of a challenge here because we're going to use some splines, and splines don't really get fully constrained. I'm getting ahead of myself. I'm going to make my spoon 14 inches because that seems like an appropriate size for a wooden spoon in my mind. But again, you can make a giant wooden spoon if you want. 14 inches is that long. It seems like a decent size wooden spoon. But maybe you got a big pot of soup and you want to make a 20-inch spoon. Mike, I know you like to cook, so you know, maybe you need like a chef's spoon, 30 inches. You know? All right. There you go, yeah. Right. All right, but 14 inches is good for me. And I'm going to go ahead and hit OK there. And now I'm going to define the bowl size of my spoon here. So I'm going to go ahead and click on the Create menu. And I'm going to go down and choose the ellipse tool. I guess you could make yours a circle if you wanted to, but I'm going to make mine an ellipse. And I'm just going to click somewhere. In fact, here, let's use some constraints here to make this into place afterwards. So I'm going to click off into no man's land here and just place the center point of my ellipse. And now I can move my mouse outward and I can define either the height or the width of my spoon. I think I'm going to choose to define the height, and I'm going to make it like 4 inches. 4 inches is a good, yeah, that's a good bowl size. So 4 inches. The way the ellipse tool works is you type in the number 4, and then you click, and now you can move your mouse up or down, and now you've got that second measurement that you can enter in here. And that second measurement for me is going to be like 2.5. Yeah, that looks about right. That looks like a spoon to me. And then I'm going to hit enter finally to place that measurement. So now I've got these measurements. I can click and drag on these and I can move them outside of my spoon so they're a little bit easier to see here. All right, so we've got our ellipse, but our ellipse is not in the right spot. We'd like the center of our ellipse to be on this line here, and I'd like this point here to exist right at that point right there. I'd like those points to exist right on top of each other. So we're going to do that by adding some constraints after the fact. So constraints in that constraint menu up there are ways that you can, there are rules that you can give to your sketch to bring it into alignment with what you want it to be. So the coincident constraint, so if we choose the coincident constraint here, if I choose the center point of my ellipse, and then I choose my line, then you can see it snaps to that line now, and now you can see I can move it right and left, but I can't move it up and down because it's forcing it to be coincident on that line. I can use that same constraint to make these 2 points exist right on top of each other. So from my constraints menu, I'll go ahead and choose the coincident option. I'll pick on the top point of my ellipse, and then my origin point there, and there we go. Now I'm going to kind of take a walk around, see if you got your ellipses to pop into place or moving in that direction still. Quick teachable moment here. Let's say you forgot to add dimensions to something. Oh no, panic! Start over. No, it's all good. So we can add dimensions after the fact, just kind of like how we can add constraints after the fact. So from our, can I morph this so it is a weird size? Sure can. Good job. All right. So from our create menu here, if we forget to add a dimension, we can come down to the sketch dimension option. And I can choose this point and then choose this point. And now I've got this number that I can just click and place anywhere. So I'm just moving my mouse around, and once I click to place that measurement, then I can type in what I want it to be. So I wanted that to be 4 inches. And I can do the same thing with my other dimensions. So my height dimension here on my ellipse. So if I choose create and then sketch dimension, I can choose this point and then click on this point second. And now I've got this other measurement that I can click and place somewhere. And now I can type in my measurement for that, which is 2.5.
Which constraint was it? That's gonna suck it onto the.
The constraint that made our circle pop onto the middle there is the coincident constraint.
So we've already given it dimensions when we're creating sketch dimensions.
Well, so you don't need to create a sketch dimension if you gave it a dimension while you were drawing it. But if you forgot to give it a dimension while you were drawing it, it's nice that you can give it a dimension later. What is always the coincident constraint? Oh, right, exactly. Coincident is the one you can't remember. Yeah. So to get our, here I can delete it, and then let me move you. Let me move you. Here, I'll do it again. So we go to ellipse, and I'm gonna make my ellipse, and then 2.5. All right, so now to make our ellipse snap into place, I'm gonna, this is a sticking point for some beginners here. If I have something selected here, it is highlighted blue, like that line or this circle. Before we click on our constraints menu, it's important that we don't have anything selected. Causes problems later. What happens is, first of all, some of these constraints you can no longer click on. They're grayed out because it thinks that you want to apply this constraint to the thing that you have selected already, and you can't make an ellipse perpendicular to something. So that's why it's grayed out right now. So I encourage people to kind of click off into nowhere, just anywhere off to the side of your sketch so nothing is highlighted. And then you can choose your the constraints menu option. That's kind of my general practice for all the tools is first you want to pick the tool and then you want to pick the thing you want to use that tool on. So I'll choose my coincident constraint here. And if I pick that point right in the middle, so I just clicked on that point there and then I'll click on the line and it pops down to the line. Cool. And then I'll do that one more time. Coincident constraint. And I'll choose the end point of my little ellipse and then the end point of my line.
All right. Yeah. Do you need to constrain both points because an ellipse is automatically set with the x-axis at 0?
You are probably correct. You probably could just get away with doing the 1 point. That is a good point, Mike. Yeah, yes, and then in the yeah, here. So no, you're all good. So right Oh, you're good. You're good. Um, edit sketch for me is the third one from the top. If I right click.
Slice sketch?
Hmm. No. Something weird is going on here. So here, click finish sketch. All right, and now try edit sketch. There we go. All right. Cool. Weird. Yeah. Yeah, something weird happened here. You were like, you had your sketch palette open, and normally you only have your sketch palette, but you also have your sketch tools. So, all right, cool. Yeah. All right, so once we have our bowl kind of defined here, this is kind of the outside of our bowl. Let's create the inside of our bowl, kind of define the inside of our bowl shape. And the way I'm going to choose to do that is I'm just going to click on the modify menu here. I'm sorry, I am not editing my sketch anymore. All right, so we're editing our sketch. And I'm going to click on my modify menu and I can choose this offset option here. So offset lets us take a sketch curve and create, in this case, a bigger or smaller identically shaped version of itself. So the sketch that we're going to offset is going to be this guy right down here. And for me, it's a negative number. Negative 0.2 brings me inside. That little red line is the new line that we're making. Negatives and positives kind of mess me up. You want to go inside your original circle. There you go. Yeah. Sometimes a negative number and a positive number does different things for different computers. So usually makes that determination. Cool. All right. And then I'm gonna hit enter. All right, cool. So right now, our sketch is what is known as fully constrained. And normally, this is my happy place. This is the goal that we want to get to. I can tell that the sketch is fully constrained because all of my lines are black. If you have blue lines, it means there's a dimension missing. You haven't dimensioned everything if you see some blue lines. Don't panic if you got some blue lines. It's going to be just fine. The reason I point this out now is because we're about to make a whole bunch of blue lines. Because we're going to use the spline tool here. It is very difficult to make a spline fully constrained. So I'm going to try to make it okay I'm going to make it okay with myself that this is not going to be a fully constrained sketch. It's a freeform artistic thing. It's cool. So I'm going to choose from my create menu. I'm going to choose come down to spline and then over to fit point spline. And this fit point spline is how I'm going to define the handle shape. I've got going on here. So I'm going to go ahead and choose this fit point spline option. I'm going to zoom in a little bit. And then I'm just going to kind of place the first point of my spline, like right about here on my spoon. Again, creative freedom. We're all about creative freedom in this class, especially when we're using the spline tool. And I'm just going to place a couple of points on my drawing here. I find that when I'm using the spline tool, I want to use the least amount of points possible to define the curve that I'm looking for. And I kind of just get this close-ish. This is not the exact curve that I'm looking for, but after I place my points, I can refine those curves later and kind of make them do, I can push and pull them around. When I'm done making this side of my spoon, I'm going to click on the little checkbox here. So there's a little check mark inside of a circle, and it turns green when you hover your mouse over it. And if you click on that little checkbox, that will finish making that spline. And now I've got all these control points and control arms that I could use to tweak my spline a little bit. So, what's that? Yeah, respline it. Yeah, exactly. I still have my spline tool in my hand right now, so I can't move any of these points around until I put my spline tool away. If you've got any tool in your hand, including the tools down here, my go-to method for kind of putting that tool away is if I just hit the escape key. Now I put that tool away. And now I can click and drag on these points, and I can refine the shape of my handle. I can also, if I click on a point and don't drag, if I just click on it one time, I get these little green handles here. This lets me, now I can click and drag on these handles, and I can change kind of the radius, I guess, that spline point is making. So if I just click on the point, and now I've got these little green arms that stick out, and now I can twist these little green arms around in whatever way, shape I see fit. Sweet curves, bro. All right, so I left the back of mine open because I'm going to draw a back part, but you can close yours off the back. You can do whatever you want. You're the bosses of your own spoons. I'm going to go ahead and I'm going to say, I'm going to create I'm going to make the other side of my spoon exactly the same as this side of my spoon. And I'm going to do that by just drawing it very carefully. No, I'm not going to do that. So I'm going to use another tool here. In the Create menu, there is a mirror tool. The mirror tool is really handy when you want to make an identical mirror of something. Hence the name of the mirror tool. I'm going to click on as the object that I'm going to make my mirror of. I'm going to choose my spline. A beautiful, beautiful spline. And as the line that I'm going to mirror over, my mirror line is going to be that center line that we mirror, that long line we drew right at the bottom of our sketch here. And I'm going to say, okay. Now, I guess you don't need to make a symmetrical spoon. If you wanted to draw the other side of your spoon with the spline tool, I will not stop you from doing that. But the last thing that we need to do here to this sketch and to our spoon's shape in general is mine is not a fully enclosed shape. So you can tell something is a fully enclosed shape. If I hover over this, I can click in this area and it highlights all blue because it's closed on all sides. Here, my handle, you can see is not closed on the side, so I won't be able to extrude out this shape. And I thought this was a really nice detail that we had on all of our spoons at Our Daily Salt. So I'm just going to kind of mimic this. I'm grabbing my arc tool, my 3-point arc tool. You could do this with a line, I suppose. You could put a circle down here if you want to be able to hang your spoon. You could put a circle in there. But I'm just going to grab my 3-point arc tool. And I'm going to click and place the first point of my arc at the end point of one of my splines. And then I'm going to click and place the other end point of my arc. Is going to be somewhere in here-ish. And I just clicked to place that point. And now, I'm just moving my mouse until I get a curve that looks like what would be Felicia approved. Felicia was the boss. You had to have Felicia approved curves on all of your spoons. Very important. All right, so I'm just gonna make a little curve like that. I like the way that kind of asymmetrical end looks. And now I'm gonna go ahead and say finish sketch. And I'll pause here and let you guys finish out the ends of your spoons. Like I said, if you wanted to, you could put a circle at the back end of your spoon back here, like a 1/4-inch circle. But I will say that part of this process is like knowing what a CNC machine is really better at. And knowing what you can do a lot faster than the CNC machine can. If you need to put a hole on the back of your spoon, you can do that at a drill press faster than the CNC machine can. I guarantee it. Unless you need to put 400 holes at a very precise distance from each other, like maybe the CNC machine is good for that. But like if you just need to drill a hole, you can do that yourself later. And this little guy down here. Yeah, that's totally fine. Some people, maybe a spline is a good way to do this. Some people like to use the trim tool. The trim tool in your modify menu here will let you cut off little bits of line like this that are hanging off the end. I don't like to use the trim tool because there's no going back from a thing that you've trimmed. So like for example, if you trim part of a circle, it's not really a circle anymore and you can't really redefine that radius on that circle. Versus if you just leave it untrimmed, it hangs off the back. At least you can change that radius later if you want to. So I kind of am not a trim tool fan. There's also this tool called Break. And what Break does is it'll take these 2 line segments and it'll take this 1 line segment and it'll make 2 different line segments with an end point right there. But again, things can move around weird parametrically when you do that. So I use at your own risk. All right, so for some reason I can't move these anymore. There we go. All right, I'm gonna say finish sketch. And now we can extrude out our shape here. So I've got a sketch I like to name here. In my sketches folder, as we create sketches, as we create bodies, you will see a couple of things happen. sketch. We've got a sketches folder. In that sketches folder over in our browser, we've got a sketch. Our sketch is called Sketch 1. That is a terrible name for a spoon sketch. So I encourage people to name your sketches as you go. I'm going to call this my spoon profile. Or spoon shape. Literally anything is better than Sketch 1. All right, so now we can extrude out our spoon shape. So if we click on the Create menu here, and we choose the Extrude option, it's also the E key on your keyboard, I'm going to go through and I'm going to pick all 6 of those profiles. So I've got 6 profiles because every time there's a line, divides up my shape. So I've got 6 profiles to click on here. And I am going to extrude that for a distance of 1 whole inch.
So you select all those individually, or was there like?
I did. So that's a fine question. So now
I see what you did.
so there's you could click on them individually, and that is exactly what I did. I went through and clicked on them individually, but you can also box select things. So there are 2 ways to use the box select tool. If I drag from top right to bottom left here, you can see that my box is yellow with a blue border. And if I let go of that, you can see that what that does when I drag from top right to bottom left is it only selects the things that are fully enclosed, fully encompassed within inside of this selection. So this is the only shapes that are fully encompassed. These shapes here are not fully encompassed, so they are not selected. The other way to use the box select tool is from top right to bottom left, and what happens in this case is this selection chooses everything. So if it touches any bit of an enclosed shape, it will get selected there. So you can kind of box select a whole bunch of things different ways by using those 2 methods. Good question.
So, I'm sorry.
You're good. You're good.
You're getting 6 profiles selected. Somehow I'm getting 8 profiles selected, and I think I drew mine as similar as yours as I possibly could. Why would I be getting 2 more?
Could be that well, your curves are intersecting, so you got a curve that comes this way, and you got a curve that comes this way. Instead of being right on top of each other, they might be like this. So you've got extra shape in the middle of them. Totally fine. It won't affect your.
Just because I got such nice curves.
Right, because your curves are so nice, Dan. But as the instructor here for Model Monday, it would be inappropriate for me to tell you that you have nice curves. And I'd have to report myself to the HR department here at the Makerspace. And I hear that person's real mean. So I cannot tell you that.
Yes, but you can say the model has.
The Model S, yes. All right. All right, cool. So, I extruded out my shape the wrong direction. So you should panic. We should start all over. What I really want is I would like my extrusion from my spoon to go the other way because I'm going to use this sketch again. And I'd like that sketch to be on the top of my spoon. So Fusion 360 is parametric design software. So you'll see down here there's a timeline of events at the very bottom of our screen. these are all the steps that we've done to get from where we started with to where we are right now. We made a sketch, then we extruded that sketch out. If at any point we want to change something that we did in the past here, I can right click on that feature in our feature timeline down here, and I can say edit feature. So for example, this extrusion, if your extrusion is coming up, you do indeed want your extrusion to go down, because we want our sketch to be living on the top of our spoon there. And now I can say, okay, now we solved that problem. All right, so we've got 15 minutes left, and I don't want to go too fast here. If I do a revolve, it's going to cut out the bottom. Tell you what, let's solve this problem, because I do want to generate some tool paths here. Instead of making a 1-inch spoon, we're going to make a real fat boy. We're going to make a 1.5-inch spoon. If we don't have to make a complicated bowl shape, it'll save us a little bit of time here, and we can get to generating some G code here. So now that we've got a 1.5, and I suppose this only works if the thickness of your spoon here. Well, here, let me show you what we're about to do. So if we click on the create menu, we can come to the revolve option. And now I'm just going to pick on 1/2 of my spoon profile here. Oh, you know what? You know what we can do? We can solve this problem. All right, good. And now I'm going to choose an axis to revolve that around. And you can see here in my revolve panel, the thing that I'm revolving is turned red. And that is because my default operation, the first time we did that extrusion, I didn't point out the operation option here. This operation option will be in every window that pops up from the create menu. There'll be this operation option. And it defaulted the first time to making a new body, because that's indeed what we wanted to do. We wanted to make a new body. If your bodies overlap each other when you're creating them, the default operation assumes that you want to do exactly what we want to do here. We want to cut. So what we're doing with this is we're cutting away this revolve from our original body here. There are two other options here. There's join. So join would make those two bodies, or those two features, it would turn them into one body. And then also, I don't use this option a whole lot, but there's also an intersect option. So you can choose the intersection between those two bodies. But cut is indeed what we want to do. And then we want to say okily dokily. I'm going to turn off the visibility on my spoon profile just by clicking on the little eyeball icon there. And I'm going to name my body spoon. I'm going to come and take a look at your spoons. Did anybody's bowl pop out the bottom of their spoon? Hopefully not. All right, beautiful. So, now that you've finished the modeling part of your spoon, I highly recommend that you save. So, I'm going to go ahead and click save. The save icon in Fusion is the 3.5-inch floppy disk up in the top right hand corner. They make it a 3.5-inch floppy disk because if it was a 5 1/4, nobody would understand what that reference was. So that's why they made it a 3.5-inch floppy disk up there. Or is it 3 1/4 and 5 1/2? Anybody? Anybody remember? Okay, cool. Yeah. All right, that's what I thought. Yeah. So again, the 3.5-inch floppy disk. You just click on that little icon. Good. Yeah. You got laser discs up there. Oh, older floppies. Yeah. More, you get a whole nother kilobyte of data on that one, which was a lot. So I'm gonna call it Spoon, and I'm gonna save it in my Model Monday projects folder here. But you could save it wherever makes sense. Fusion saves everything in the cloud, so this is what you're doing right now is you're saving things to your cloud storage. Where Autodesk can sell all your models to China. I don't think they actually do that. That's I'm sorry I said that. Autodesk is a wonderful company, and they give us this program for free. So thanks. All right. So now that we've saved, now if we want to actually make this thing, if we come up to the top left-hand corner where it says Design, and we come down to the Manufacture option. You're going to have the computer is going to manufacture this spoon for you. You won't even have to do any work. Barely break a sweat. The first thing that we need to do is we need to generate a setup. So a setup is a basic bit of information, mostly about what you're cutting this out of. So you've got a piece of stock. In theory, we've got like a piece of wood. So if I say setup, and then I come down and say new setup, does anybody Z-axis point in a way that is not like mine is? It all points up. Oh, okay, cool. I guess we could go through this anyway. There will be instances where this is what you want. You want your Z-axis to be pointed up and away from. You measure your Z-axis as your tool. That's like where your tool shape is, right? There will be instances where this will not be set up correctly right off the bat. So. Correct. Yeah. If for example we had drawn on the front plane, this would not be oriented correctly. So where it says Work Coordinate System (WCS) here, I'm going to click on this orientation drop down. And I'm going to say, hey, I want to select the Z-axis / plane and the X-axis. Either one of these second or third options will do, as long as the first part is Z-axis / plane. So again, I'm going to choose Z-axis / plane and X-axis. Now I can select here the Z-axis. I can select any flat surface that is normal to that Z-axis. So this top of this spoon, that is normal to our Z-axis. And now I actually don't need to select an X-axis. It is already defined one for me. So this is kind of superfluous. I don't need to define an X-axis. I really just need to make sure my Z is pointed up and away from my spoon. Cool? No?
Is that because most of the machines here go to -Z to plunge?
Well, so it's because like we wouldn't be able to, if our tool was cutting in the side of this, we wouldn't be able to carve out our bowl. So we need our tool to be kind of cutting downwards on it in order to cut our bowl out.
Makes sense.
Yeah, but we all have Z-axis pointed away. Yeah, sweet, sweet. part of this, or the next part of this is this little widget here. This is our 0, 0 point on our CNC machine. So it's the point at which the machine thinks is 0, 0, 0. And although you can find a midpoint on a board, in fact, at the wood shop, this is how we used to do it. We used to have all the zeros right in the middle of our wood, and then we draw a line from corner to corner, and we line the tool roughly up in the middle of that. So you could leave it there. I think it is much easier to locate your 0 on a corner point. So I'm going to click on this little widget here, and then I'm going to click on the corner point so that both of my arrows point back towards my part. So once you've clicked on the origin point, you can select any of these box points as your 0, 0, 0. And then the last thing we need to do here is in our setup window, if we click on stock, and instead of the mode that is a relative size box, I always like to recommend people choose a fixed size box. So when you go to make this thing, you're going to have a physical piece of wood. So instead of mode that is relative size box, we're going to choose mode that is fixed size box. And we're going to take our piece of wood that we've got in the real world, and we're going to measure it. And we're going to say, hey, look, my x-axis is 16 inches. And my y-axis is, look, I've got a 4-inch board. I'm going to cut my spoon out of that. So to actually have your real world measurements from your actual piece of stock, input here as your x and your y and your z.
So I'm finding that these are metric values. Does it mean that the less I did is a metric as well?
You're going to have
Very small spoon.
it's a small spoon. It's the kind of spoon that they would use in a European country to put the sugar into their espresso. It's like an Italian spoon, Dan. Do you sail to Italy? Have you ever sailed to Italy?
Yeah, I've gone to Cagliari.
This will be perfect for your next trip to Italy. All right. This might be a pain in the butt.
I could just go back and make everything in my sketch into inches.
You could, yes. Because you're going to have real small tools to actually make that spoon. Do you mind if I keep going?
Yes.
Okay. You mind or?
No, you answered my question very well.
Okay, right on. All right, so now we can actually make some tool paths here. So the first tool path that I want to make is I'd like to carve out my spoon middle there. So if I come to the 3D option, and I believe parallel is what we want. Yeah, parallel is what we want. So Fusion 360 has really great tool tips, especially here in the manufacturing area. So if you've not used or you're not sure which tool path you should try making in order to cut out the thing that you want to cut out, these tool tips do a really good job of showing you these blue lines are the path that the tool is going to make as it's spinning around, cutting out your bit there. These tool tips are really fantastic in the manufacturer area here. So I like these a lot. So I'm going to come up to this parallel option. The first thing I want to do here is I want to select a tool that we're going to use. So I'm going to come over here to this select option. I'm going to come over here to my milling tools inch over in the left-hand column. And I'm just going to scroll down until I find my nice flat 1/4 inch and mill. Hopefully you guys have tools there.
You had to click on select enable tools.
Okay, cool. So it's 1/4 inch flat and mill.
So milling tools. And they're by size, so you have to just kind of scroll down until you see 1/4 inch flat.
Yeah, and I actually found that in the drawing, or in my units were inches and the manufacturing was no.
Oh, cool. All right, right on.
So I may be able to salvage this.
All right, so I'm going to go ahead and say select. Is it okay if we run 5 or 10 minutes over? All right. Okay, cool. So we've got our tool selected. Disclaimer time here. So I don't really talk about feeds and speeds in this class. Feeds and speeds are important, and you should ask the internet or the appropriate maker here at the makerspace about feeds and speeds. I don't talk about them because I don't know what tool you're cutting with. I don't know what material you're cutting on, and I don't know what machine you're using. So I don't want to tell you what numbers to type in here because then people say, hey, Carl told me that I should type in, and then I broke the thing, and it's because I don't know a lot of things. But there are feed and speed calculators on the internet. And I can tell you that the tool that we're going to cut out on will go like 16,000 RPM. So, or the big 5 by 10 back there goes like 16,000 RPM. So, you know, you can set it at 14 pretty easily. And in general, my cutting feed rate, I'm going to set to like 60. And then my lead in and lead out, I'm going to set to half of whatever my cutting feed rate is. And my plunge, I like to set my plunge at even less than half. Flat end mills don't really like to drill very nicely. So, you know, I went with transition is. So my main cutting feed rate here, less than 100 for sure. Depending on the material you're cutting, if you're cutting foam, you might be able to go 100. But like, this is going to be a good starting place for me. Again, I don't really talk about feeds and speeds, but we need to type in some sort of numbers here. So this will get us going here. And then, like I said, talk to the appropriate maker here at the makerspace before you use a machine with these numbers. Cool? All right. So now the last thing that we need to do here is, sorry, not the last thing. The next tab over in our little parallel window here is the geometry tab. This geometry tab will let us define a machine boundary. So right now the machine boundary is set to its silhouette. So that's basically the machine boundary is the whole thing. In fact, don't click OK, but I'm going to click OK right now. So this is the tool path that it will make if you're set to machine boundary. It'll run over the top of the whole thing. And really, that's just kind of a waste of time. So The option that is better for silhouette in our case is going to be a selection. We're going to tell it where our machining boundary is. So if I choose this selection option and I pick the upper ring of my spoon bowl, you can see it turns green there, and we've got a closed chain selected, which is good. And now the very last, actually, yeah, passes. The fourth tab over is our passes tab, and we need to set a step over. So again, this depends on the tool that you're using, how deep down the tool is cutting. There's a lot of determining factors here, but and also like surface finish. Surface finish is definitely a thing. When we're talking about the interior of our spoon, we want it to be a nice surface finish because we don't want to have to do a lot of sanding there. So I'm going to set it to 0.02. Quarter-inch bit. We're only cutting down like 3/4 of an inch. So at 0.02, that'll be perfectly fine chip load for most quarter-inch end mills. But again, it's like feeds and speeds. I try not to talk about them. This is why we don't do a whole lot of CNC stuff in this class, because I don't want people blaming me for broken machines. All right, cool. So now I'm going to go ahead and say Oakley Dokley.
Okay, when I did like select the ring, it didn't say chain.
Oh, did So it just says chain. Try just let you say okay. Try clicking on okay there and see what. There you go. Yeah, you're good. You're good. You're good. All right, cool. So it made a bunch of blue lines on the inside of our spoon. That is indeed the tool paths that the 1/4 inch end mill is going to run in. The last thing that we have to do in order to cut out our spoon is we need to kind of run a profile around the outside of our spoon here. So in the 2D section.
So, oh, I think
Oh, yeah.
it popped up.
That's totally fine. Yeah, so if you click on setup. There you go. Yeah, it was just showing you your stock and the material that you were cutting away there. And I'll show you at the end, we'll simulate that look. All right, so now we'll go up to 2D and we'll come to 2D contour. Now, we don't have to select a tool because it remembers the last tool selection we made. We also don't have to redo any of our feeds and speeds here because it remembers this from the last option. If we change our tool, I'm not sure if our feeds and speeds will stay the same or not. But I don't know if it's married to this tool for this particular job, but it remembers all those things, which is nice, assuming you want to run at the same feed and speed for each of these different operations. There could be reasons that you would not want to do that from a surface finish or just a speed perspective here. But two things we do want to do in this area is in our geometry tab, we want to tell it what is the contour that we're cutting out. And the contour that we want to give it is the bottom edge of our spoon. So if I hover over the bottom edge, it kind of all highlights black there. And it says contour selection. I'm just going to click on that. So it'll give us a blue line with a red arrow pointing in one direction. I want to add tabs to this workpiece, to this contour here. So what will happen is I'm going to have my piece of stock is going to be fastened down to the tool bed in some way, shape, or form, or in a vise somehow, maybe. But presumably screwed down to one of our router tables. And once it gets done cutting out the shape, if it's just all loose, your tool is still down in there, so it starts wiggling around and gets damaged. So if you add tabs to the outside of your piece, it'll leave a tab every once in a while. So I'm going to click that little tab button. I'm going to change my tab distance. Instead of 2, like probably 4 inches is probably plenty. Depending on your material that you're making the spoon out of, you may want to change the height and width of your tabs. Some kinds of wood will have a better tab resolution than others. You may need to have a 1/4 inch by 1/4 inch tab. We're going to be sanding the crap out of this spoon after the fact anyway, to give it its curves. So I wouldn't hesitate at giving it some beefy tabs that hold onto it real good. Because like I said, you're just going to be sanding the crap out of this anyway, and these little tabs aren't gonna hurt you. The last thing that we want to do here is, again, don't click OK, but if I click OK, what it's going to try to do is it's going to try to cut this full depth all at once, and this full depth is the full width of your cutter, so a full 1/4 inch width all the way down 1.5 inches. That will probably definitely be too much for the machine or your cutter or both. So what we want to do here is we want to have a different, in the passes tab here, near the bottom there's this option called multiple depths. And if we check that check mark, and then we scroll down in our window here, we can set a maximum roughing depth. I think a general rule that I use is half of the width of your cutter is an amount that you can go down in one pass. So if you've got a 1/4 inch end mill, I can go down 1/8 inch every pass. So I'll just change that maximum roughing to 0.125. And then I'll say OK. And now you can see it makes a whole bunch of blue lines around the outside there. All right, so now you've got your tool paths generated. If I click on any one of my tool paths over in my setup folder here, I can see the lines that make up that tool path. If I click on, and this is important, now when I click on my setup folder, so my setup folder is highlighted. And now if I come up to the Actions menu here, I can say Simulate. So, you will probably notice along with me a whole bunch of red down here. Red lines all day long, right? This is Fusion indicating that there is a problem with your toolpath. So if I hit play, we can see the tool, or the problem with my toolpath is the cutter of this whole thing is running into the top of my material because my end mill is not long enough. So I wanted to point this out because these red lines, they're pretty important. Now you can just be conscious of it'll still let you output this code. And I leave up to your discretion whether you want to output the code like this, because you know, hey, my 1/4 inch end mill is not the 1/4 inch end mill that's in here, and it's going to work just fine because my 1/4 inch end mill is going to be plenty long. But if you're like me, you want to fix this problem instead of just moving ahead with it. So if I right click on any one of the tool paths that I used that tool on, the second option, which is off the screen unfortunately, is called Edit Tool. So the top option is Edit, and the option right underneath that is called Edit Tool. So again, I just clicked on any tool path that I made with that tool. And I just right clicked on it, and then you say Edit Tool. And now, if we click on the Cutter tab, I can change the length below the holder. So this is our problem unit here. So the length below the holder is 0.85 inches. And you will remember our stock is 1.5 inches, which is indeed not long enough. So I'm going to change that to be a 2 inch. It's probably unusual to find a 2 inch cutting length. So like I would really change it to 1.5 inches because that'll be long enough. But it's an important number to think about, how many inches you can cut at once. And then I'm good. And then I think the rest of it will be just fine. Then I can just hit enter, and I can say accept. So now I've got some little orange arrows here, or orange circles and orange arrows. You guys all have those orange arrows and circles too?
Right, so when you did
So
adjust the length of the tool.
yeah, so I clicked cutter and I adjusted the length below holder number to be 1.5 inches.
I got it read and I was at 2.5.
Well, the whole cutter might be 2.5.
Length below cutter, okay.
Yeah. Yeah, the overall length is 2.5, but it's the amount that sticks out below the holder is the problem. Cool?
Yeah, now I'm orange.
All right. So now that we're orange, what that really means is you've changed something about your tool. And if we right click on the setup, we need to tell it to generate. So I right clicked on the setup folder, and then I hit generate, and it'll do the little circle things, and it'll give you the little green check boxes.
Underneath the tool setup?
Underneath the setup folder in your browser, if you right click on your setup one, and then say generate. There you go. Cool.
I changed mine, but mine never gave me any red alarms with the 0.85.
Oh,
It
alright.
showed that it would work perfectly.
Alright, cool.
So the one thing that I've got that's different is your toolpath one, you're having parallel. And this is probably something that I've selected, minus the face. Is that different?
It is definitely different. Yeah, so a face isn't going to do the bowl shape. It'll just do like a flat surface.
So is there a way to modify that to be different to the toolpath?
No, I think you just have to choose. I don't think you could change the type of a toolpath it is after it's been created. But I do want to show everybody how to export this before we're done here. So now that we've actually made this thing, I could choose simulate again, Oh, I'm still getting a bunch of red. Why am I getting red? Oh, because my cutter is not really long enough to do this. The amount I can cut is less than the length of my flute length. My flute, I can only cut 3/4 of an inch of material with this cutter, and I really need to be able to cut 1.5 inches of material with this cutter. Now I don't have a tool that's long enough, so I'm going to make this a tool that is actually long enough to do this job. Shoulder length must be larger than flute length. So that's going to have to be 2. Length below holder must be larger than the shoulder length. So this is where it's like you measure your actual tool and you type in your actual tool information here, because then you're not jumping through hoops like this. Right. So if you measure your actual tool, and your actual tool is long enough to actually cut the job you're actually trying to cut here, now we'll generate, and I can simulate this, and now you can see that I'm all green. I could push go here, I could push the play button, and I could watch it do its thing in fast motion, cut out all of its things here. But more importantly, with my setup folder selected, I can click on the actions menu and then choose the post-process option. And post-processing will let you output it to whatever CNC machine you're actually cutting it on. So it'll actually make the G code that sends it to the CNC machine. Here at Linux, the machine, the 5x10, is UCCNC. This is the post processor. Not every machine, a lot of machines will have different post processors, but we use UCCNC2 here on the 5x10. I believe the Bridgeport uses Mach 3. Bridgeport at the other building, at the Linux building, is Mach 3. I believe the 4x8 at the other building is also Mach 3. But I'd have to, it's been a minute since I've used that one, but UCCNC is what we use here in this building. We can have a file name. You know I like naming things. This is our spoon. It's our 14-inch spoon. The file name appears, it doesn't need to be the name of the file, but it certainly appears as at the top of your G code when you're running it. The other thing that appears at the top of your G code when you're about to run it is this comment line. And I always, in my comment line, write the size of the cutter that I planned to use when I made this file. So when I actually go to cut this out, I can see right at the top it is labeled, oh, I'm supposed to use my 1/4-inch flat end mill here. So I always write that comment at the top. You can put a whole bunch of stuff in this comment. I don't know if there's a character limit, but I have not reached it. So you can type in how many operations it's going to do, what it's going to do first, what it's going to do second. Future you will think that past you was a genius, and future me almost never thinks that, so you should pat yourself on the back if that happens to you. We're gonna output it to my desktop here. Yeah, and then you hit post.
What do we have no machines like in your library?
Oh, do you not? Is that a thing? Here, I'm gonna say goodbye to the folks on the recording, and then I'm gonna come and walk around and see how everybody's G code looks.